Imagine standing in front of 3 doors. Behind one of them is the car of your dreams. Behind the other 2, just goats. The host asks you to pick one door. You choose door 1, but before you can open it, the host opens door 2, revealing a goat. Then, with a smile, the host asks, "Would you like to switch your choice?" In other words, do you want to switch to door 3? Right now, you're standing at the crossroads of logic and instinct. You think, I picked one door out of 3. Now 2 remain. One has the car, the other a goat. So switching or staying should both give me a 50-50 chance, right? Actually, no. According to probability theory, if you switch, your chances of winning the car double. This is the famous Monty Hall Paradox. But it's more than just a numbers game. It's a mirror that reflects the cognitive biases of human thinking. A precise, cold, even slightly cruel philosophical trap. Back to the game. In reality, most people choose not to switch. Why? Because we instinctively believe that once there are 2 doors left, the odds are evenly split. And that's exactly what makes this paradox so brilliant. It doesn't defy math. It challenges intuition. We naturally prefer to see the world as symmetrical, static, and linear. We think standing still means safety. We believe that probability is always fair. But the truth is more complex. Let's break it down. When you first picked door 1, you had a 1 in 3 chance of picking the car and a 2 in 3 chance of being wrong. Now here's the twist. The host always opens a losing door. He knows where the goats are. So when he opens door 2 to show a goat, he's not acting neutrally. He's passing along hidden information. By doing so, the full 2/3 chance of being wrong shifts to the door you didn't choose, door 3. So when you switch to door 3, you're not just guessing. You're absorbing the probability of your original mistake into a smarter new choice. Winning the car isn't luck. It's an information advantage. You didn't get lucky. You updated your decision based on how information moved. It's almost as if the universe is whispering. Intuition won't save you, but logic might. The Monty Hall Paradox is so compelling, not just because it challenges our sense of math, but because it feels like a metaphor for the cosmos itself. In real life, we often assume fate is fairly distributed. We think effort and laziness each get their due, that success and failure are evenly balanced. But what if life, like this game, has an invisible host, nudging outcomes just a little? After we make our choices, what if the universe runs on some kind of feedback system where every decision triggers an unseen update? And if that's true, can we still believe in free will? In quantum mechanics, this idea isn't far-fetched. Take the quantum measurement paradox. Every time you observe a particle's position or momentum, its state collapses into something definite. Before observation, it exists in a superposition of all possibilities. Sounds familiar, doesn't it? Just like the unopened doors in our game. Before you make a choice, before the host opens one wrong door, the car could be anywhere. It exists in a cloud of informational uncertainty until you observe, choose, and update. Speaking of quantum measurement, we have to mention Schrodinger's cat. A cat is placed in a sealed box, along with a poison device triggered by quantum decay. Until the box is opened, the cat exists in a state of being both alive and dead. Only when observed does its fate collapse into one reality. This bizarre superposition and the collapse caused by observation lie at the heart of quantum theory, where reality and observation are deeply entangled. And in delayed choice experiments, particles can even decide retroactively, as if their past behavior depends on future observation. This quantum weirdness forces us to question whether time itself is just the illusion of how information flows. Back to our game. You'll notice the entire paradox revolves around the movement of information. Your initial choice sets the stage. The host's action adds a new variable, and your decision, switch or stay, determines how that new info is used. This is the essence of Shannon's information theory. Information exists to reduce uncertainty. When a host opens a door, he's compressing entropy, reorganizing chaos into something that can guide your decision. So, could the universe work the same way? Are our choices filtering some larger, hidden structure? Is human consciousness just a side effect of nature running decision models and compressing data? That's not just physics. That's philosophy. Do we really choose? Let's go deeper. If switching is always the better move, why do most people refuse to do it? Psychologists call this the status quo bias. We tend to stick with our first instinct, even if it's wrong. We'd rather lose by our own choice than trust cold math over our gut. So maybe our free will isn't so free after all. Maybe it's just an illusion, crafted by biology, psychology, and culture. And if every possibility plays out in parallel quantum universes, then perhaps every choice we make is just flipping to a different page in a book that's already written. If the universe is one big Monty Hall game, then who's the host? Is it the laws of nature, quantum randomness, or some higher dimensional intelligence we haven't even begun to comprehend? The Monty Hall Paradox isn't just a logic puzzle. It's a test of our mental boundaries, a hidden structure beneath every choice we make. It reminds us that the world we believe in may just be a rough approximation, a fuzzy version of how information actually moves. We're trained to believe in fairness, in randomness, but reality, like the quantum world, is sneakier and far more misleading. Making choices isn't like moving pieces across a fair board. It's more like navigating a maze of missing data, cognitive traps, and misleading instincts. So now we return to the game. You stand before the doors. The host smiles, waiting. You know that switching gives you the better odds, but you hesitate, not because you don't know the answer, but because your intuition refuses to accept it. And that's the true nature of the universe. It won't make itself easy to understand, but it will give you clues. It will give you doors. It's up to you to choose. Maybe our entire lives are like this game, a never-ending series of choices. Each decision, each turn, a portal into the unknown. What we experience might not just be fate playing dice, but an ongoing dialogue with the cosmos. Behind every overlooked door, there could be mysteries waiting to be revealed. And all we can do is keep choosing and keep moving forward.